Okay, that genuinely did take way too long, so I'm going to do a second attempt where I really try and not spend way too long talking about stuff that doesn't matter. So, the first thing to talk about is this helper function. This is going to run about 1 billion times when this program executes. That's not just me saying a large number. I genuinely haven't done the exact math, but it's about 1 billion. This checks to see if two words have a letter in common. Oh, right, I got so excited to hurry that I didn't even explain what the program does. Program checks all the 5-letter words in Wordle's dictionary to try and find 5 of them that don't have any letters in common. This turns out to be you can write code to solve this incredibly inefficiently or incredibly efficiently, depending on how much you know about programming and math and stuff. We have some polymorphism stuff here that I don't care about, and this just exists. I stored the output from when I ran it for real in a text file, and this prints that out because it takes 4 hours to do it for real currently. So if you do it for real, we first this is the one that reads the output. This is the one that loads in the file. We load in the file, and then we sort each of the words, the letters within each word alphabetically. Then we remove any word that has the 2 copies of the same letter, as well as any word that is an anagram of some other word that's already in the list. And we log what time we started running this at, and then the real loop begins. This is a for loop layer, nested 5 layers deep, which is unfortunate, but I haven't figured out a way around it. And then as you can see, there's a lot of calls to match letter here, and its match letter is going to get called approximately n to the power of 5 times. The list of words is 6,000 words long after pruning, hence it's going to be somewhere around 1 billion. There's a lot of pruning that happens that culls a lot of those calls, but it's still a lot. If we actually find one, we print that out. We log how long it took to find it. And then this keeps track of how much time it has taken halfway through. So if I actually run it, we have this polymorphism stuff at the beginning. I'm not going to do that again. I'm just going to skip straight to that. I'm going to say do it for real. And you can see it does all of the pre-processing in like a second. And now it will, if I just let it run, it would take 4.5 hours to actually find these words. Obviously, I'm not going to do that. The whole point of this was to be a shorter version, so we stop that. But we can see the archived output from when it did run for real right here. And we can see each one of these represents checking 50 words for the first of the 5 words, that is. So after getting through, that's something like 500, we actually found one. And we found a total of 10. And it depends on what dictionary you use. This is, Wordle inspired this, so we're using Wordle's dictionary. But you can use more lenient dictionaries that include more words, and it makes it easier to find them. But yeah, some optimizations I'd like to make to this. If after sorting the letters in the words alphabetically, you then sort the words themselves alphabetically, you can make an index of like where's the last word that has an A in it and the first one that has a B in it and stuff like that, and you can prune a whole lot more comparisons out that way. The other thing you can do is you can represent each letter of the alphabet as a bit, cast your 5-letter word as a 32-bit integer with 5 ones in it, and then if you have 2 words, you can run a bitwise AND on it, and as long as it equals 0, it means that you don't have any letters in common between those words, which is so much faster than match letter, which is what I'm doing right now. I did optimize this somewhat, but it really doesn't hold a candle to what the bitwise ANDing would be capable of. I remembered there was something bitwise about it in the fast one, but that was all I came up with, and that doesn't really speed it up at all. All right, so that's the short version. Hopefully this one's a reasonable length.